Okay, so can you see the presentation?
Yes.
Okay, so we are 4 people in the team of Deep4hack. Myself, Maciej, Mateusz, and Kacper. We are from the University of Science and Technology in Wrocław, and one of us, Kacper, is from the Warsaw University of Technology. So just to jump right in, these are some screenshots from our application, which is currently deployed. So what you do in the first step is select if you want either upload a video or audio file, then you upload it and see a preview of what you just currently uploaded. For the video recognition task, you can select how often our model should be applied. So what is the frame interval in seconds? Here we have every 1 second the model will be applied. And after it is done, you can see the model predictions. So the timestamp means which frame on which second it was. So for example, in the 0th second, like we have here this castle, we can prediction see of grass, of a landscape, of rocks, like this castle is predicted as rocks, and of trees, of course, as there is many of them present. And this is done for every extracted frame. Yeah, and this is the first view we present. And just below that, we can see some statistics. So first, the histogram of the occurrences of all given labels. All of these plots are plotly plots, so we can zoom in, hover over them, see some details. But yeah, this is a presentation, so you can see that. The second statistic we see is how often a label was predicted during the timeline. So here we see that one label was always predicted. It is the forest one. And we have also a cumulative plot, so how many labels in general were predicted during each time frame. When it comes to the audio part, similarly, you choose audio, upload it, you can hear it. You have some algorithm settings, as we prepared 2 versions of our algorithm, which I go into detail a bit later. You can select options for those algorithms, like the window size, so how many of the time is aggregated into a single processed window. Also some generations of synonyms, and so on and so on. And then as the model output, we see that in the time range of the, let's say, 0th second to the 9th second, we have a text like woleliby, Ratowska leży w powiecie nad Ciaskiem, etc., and the predicted labels in each such window. This is the output of the ASR that we do. And on the right, we see all the plots like I described for the video part. It's exactly the same, but applied on the outputs of the audio model. So which model did we use for the image part? So for the image part, we used the SA-Res Next 50 architecture, which is a pre-trained model, which we then fine-tune. Also, we added a custom MLP after that to train it for the downstream task of multi-label image classification. We used a cosine annealing learning rate scheduler to work better with the learning rate. And also, as it turned out that the strategy to choose a single threshold for every class is kind of not working the best, we choose to adjust them for every class on its own. For the audio part, as mentioned, we have an audio, we want text. So first we use an ASR module, which is based on the popular Clarin library. It works in Polish. Then it labels us, at this moment, a word was detected. We aggregate this into time windows as given by the user. We process it into lemmas. On the other hand, we have all the classes and the Polish translations for those classes. Some of them were a bit problematical, like cultural institution. It does not have in the common sets one word in Polish, so we use many words to describe it. For each of them, we also apply lemmatization. And all of these, both of those inputs are then inserted into the either similarity-based method or embedding method. Just a few words about them. Similarity checks the intersection between synonyms of the words describing each class and the lemmas of the detected audio file. And for the embedding one, we use the distances between word embeddings from word to vec, between the detected text, and between the embeddings of the classes. All right. For the technology stack, keeping track of experiments is always hard in machine learning, so we trust in DVC, one of the most popular tools for tracking. We highly recommend it to use. For the NLP tooling stuff, as mentioned, Clarin PL tools, also Spacey. For training our deep learning models, we used PyTorch, and to prepare the POC or the UI application, we used Streamlit, which was also mentioned previously and is a really, really nice app. For the final architecture, how we deployed it, so we ordered a free domain.ml, then we prepared 3 Docker containers, one with our Streamlit app, which reads the PyTorch model, and 2 other containers which perform the ASR, and also keep track of word-to-vec embeddings, lemmatization, etc. So the app will work much faster than reading it on each request again. And thank you for your attention. That is all.
Cool. Thank you, Peter. Thank you, Deep4hack team, for the